All right, these are the day 2 notes, and we're on kind of day 2 of graphing applications. So let's practice writing an equation for the parabola here. So it looks like we have a vertex down here, and we also have some intercepts. So we could do either one. First thing we have to kind of determine is this parabola stretched, right? So we really need to be cognizant of that a value. So because that a shows up in both forms, right? We have, actually let me go back to green here. We have the vertex form, which is a x minus h quantity squared plus k, and we have the intercept form, which is a times x minus p times x minus q. So that a is super important. So let's take a look here. We're going to zoom in, and the grid's not that good. It takes, but we're looking at this. We're going over one box, which is here, and it looks like we're going up. I'm trying to find the line here. It looks like we're going up 2. So we're going over 1 up 2, and what that tells us, if we look at the pattern, right, it's usually 1 and 3 and 5, but this isn't 1. This isn't 1, this is 2. So we must have 2 and 6 and 10. That must be the pattern. So we must have an a equal to 2. So now that we know that we can put a 2 here and a 2 here. And then we can just grab, let's go ahead and do the vertex one. The vertex is 1 minus 8. So that's x minus 1 plus a negative 8. Which is equal to 2 times quantity x minus 1 squared. Excuse me, I forgot the power there. Did I forget it up there? Nope. Okay, now I got the power in all spots. Minus 8. So that's the vertex form. Now let's look at the intercept form. So we got our 2, we got our x, and we need our p and our q. And it looks like our p is negative, so our p is negative 1. It's right here, and our q is 3. And those are interchangeable. Okay, so cleaning that up, we're going to call this a plus 1. Plus 1 minus 3, right? Minus negative is a plus. Okay, so there are the equations for in both forms for that parabola. We did both because they were pretty easy. I don't think we did both, right? We have both forms there. It's really a choice as to which one is easier for you. I think there's a lot of personal preference there. But today's focus is looking at the parabola from a tabular standpoint. So this is a table. We call this a tabular application. And so we're looking for those values those intercept values you can find pretty easily on the table. So an x-intercept is an x value where y is equal to 0. So here is an x value where y is equal to 0, and here's another x value where y is equal to 0. So those are the x-intercepts. And then we have a y-intercept, kind of a random thing, but we know that, let's see, I'll pick orange. Going back to the graph here, or pink, this is the y-intercept, and it really doesn't have anything to do with the equations for a parabola, but it is a convenient point. So we're just going to highlight that here. This is a y-intercept. Doesn't have anything to do with the parabola, writing the equation, but it does allow us to do a couple of things. It is another convenient point because it's a point whose coordinate is 0. Okay, so it says write an equation for the quadratic formed by the table above. And we're back to having the same problem of what is the value for a. So that's the problem, because we can't write the equation without knowing the value for a. And so this is where the strategy we use here is we adopt, we take one of those forms of the quadratic, and we have to solve for a. And of course, it's really hard to find the vertex in a tabular sort of thing, right? We don't quite know where that vertex is, the highest or the lowest point, depending. We don't even know if this is pointing up or pointing down. So we know that the vertex is hard to find in the table. So we're really relying then on that intercept form to enable us to find a. So we're going to write that intercept form. It's y equals a times the quantity x minus p times the quantity x minus q. And we're going to put in, we don't know what a is. We're solving for that. We know what p is. P is 2. So we're going to put in 2. So that's one of the intercepts. And q is 5. So we're going to put in 5, and I'm putting the minus signs with them because they appear in the equation. And then in order to solve for a, we need an x and a y. And that is where the y-intercept comes in handy. You could use any point in that table, but the y-intercept gives us an x value of 0. And so that is really convenient because 0 is a lot easier to do calculations with than any other point. And actually, give me a second here. I'm going to get rid of that and make it a blue bracket just for my color coding. And so when x is 0, just like a table here, when x is 0, y is 10. So we're going to put a 10 out here. And now all we have is a left. And we can solve for it. Okay, so what we have then is, I'm going to stop the color coding. We have 10 equals a times -2 times -5. Well, -2 times -5 is 10. So we have 10a equals 10, divide by 10. We've got a equals 1. So this points up, and we have our regular 135, I'll call it regular, right, our regular 135 pattern. So that means that our equation for this must be 1 times x minus 2 times x minus 5. Okay. And so now we know that those are the intercepts. So a quick little sketch here, just because I'm a visual person, I don't know about you, but so 1, 2, 3, 4, 5, we've got intercepts at 2 and 5. Okay, so we know that right in between those intercept points is where the vertex is. So we're going to find that vertex. So so we're going to take those intercept points, and we're also going to look back at the table here, because we know parabolas are symmetrical, and so we can see that symmetry in the intercept points, obviously, right? They have the same outputs. We can even see the symmetry here with 3 and 4. So we know that our parabola must be right in between there. So I'm going to average and find that vertex. So that's the x-coordinate of the vertex. That's the h. So h is, I'll just call it, well, no, I'll call it h, is the average of those two. So 2 plus 5 over 2. So 2 plus 5 is 7, divided by 2 is 3.5. So that's the x-coordinate of the vertex. We could have done it with 3 and 4 as well, right? 3 plus 4 is 7, divided by 2 is still 3.5. And then finding the y-coordinate, the k. So maybe I should, say this is the x-coordinate, right? The y-coordinate, because I'm going to pull that equation here, 3.5 minus 2 3.5 minus 5. So that looks like 1 times 1.5 times negative 1.5. That makes sense, right? It's right in the middle. And that is negative 2.25. So that is our H. And so our vertex then is 3.5, lots of decimals here, and negative 2.25. So that's our vertex. And so it would look something like, you know, maybe about right here. And then we could kind of draw that parabola like that. Okay. Let's take a look at writing the parabola for this shown. So we definitely have intercepts here, but notice they give us this third point, right? So we have the x-intercepts here. What was I using for intercepts? I was using blue. Okay. We have our x-intercepts there, and we have this third point out here, and we have to have this third point in order to find A. This is going to be our finding A point. Let me put A in quotes there. So we are going to, we'll get that vertex form down. It's y equals a x minus p times a quantity x minus q. And we're going to use, so we're going to use, let me color code this as x and y, and we're going to use this as p and this as q, and we're going to put all that in and solve for a. So what is y? Y is negative 3. Negative 3 equals a. I was color coding a as red before. There we go. And then we've got our x value, which is also negative 3. It's kind of confusing, but this point over here is at negative 3, 3. So this is also negative 3. And p is negative 2. So we're going to have a minus a negative 2. That's kind of tricky, right? But we're subtracting a negative p. And then the x again, we're going back to that x, which is negative 3. And then the q is, I picked the q to be the positive one, so this is minus a positive 3. Okay, so we got some math to go through there. So we have negative 3 equals a times the quantity. I'm going to stop color coding. Okay, so let's take a look at this. This is negative 3 minus a negative 2. That's like a plus. Let me just make that comment here. Minus a negative is a plus. So that whole thing then is negative 1. And negative 3 minus 3 is negative 6. So we have minus 3 equals a times 6. Or the way we would really write that is 6a. So we're going to divide by 6. And we have a, excuse me, equals negative a half. So our table is, first of all, the parabola is upside down, so a negative a checks, right? That means it's upside down. And it's a half, so instead of the 1, 3, 5, it's a half and 3 halves and 5 halves in that movement table. So our equation then looks like y equals negative 1/2 x minus p, which was negative 3. I'm looking at the purple stuff here. I'm sorry, I'm not looking at the purple stuff. I'm looking at the blue stuff, so I did that wrong. That's a common pitfall there. Negative 2, there we go. X minus a positive 3. And let me clean that up a little bit. That's negative 1/2 x plus 2, right? But that's what happens when we have that negative intercept, and x minus 3. So there's the equation for that parabola. So looking at the skill work, this is pretty intensive in the algebra category for our learning targets, we're really looking at our strategies for writing quadratics. So, writing quadratics. Right, that's the title of this this section here, writing the equations. So writing quadratics. So we have to identify x-intercepts, and then other easy points like a y-intercept, and then we need one more point. And I'm going to put in brackets a y-intercept. Is if you got that, that's like the bee's knees. That's awesome, because that's the most convenient point. As it has a 0 x value, and then we have to solve to find value for a. Right, that was the algebra intensive. Learning target 2 is to use symmetry. That really helps us a lot, especially in the table. So we're going to be look for duplication in outputs. In other words, the y values. And then that way you can find, when you find the duplication, you can find the x coordinate for the vertex, and you can find the axis of symmetry. Right, you can identify those things. Okay, so the check your understanding is going to take you through writing equations for the parabolas. So in this case, we're going to definitely need vertex form here because we have no intercepts. So we're really restricted in that case. So we definitely need the vertex form here. And we're going to need, in this case, then we have to find a by doing this, right? So it looks like a is -2 because we went over 1 and down 2. And then we're going to, these are both tabular, right? It's just that they're giving you the table in kind of right in the equation here. But those are 3 points right there. So practice writing that using the intercept form. So these would be intercept forms to practice writing and finding that A. And then you can check your work in Blackboard. We have the solutions to the check your understanding, and then you can go on to the homework.